a wonderful event and a wonderful organization. I think that the goals of this meeting are very exciting, and I think that there's all the pieces in place to make it very successful, and so I'm very, very proud to be part of it. But I like to begin by giving a disclosure that I do not claim to have any gifted insight. I don't believe I do not have all the answers. My life has been unique like everybody else's life. I spent 10 years in industry at the Polaroid Corporation learning to do chemistry. I spent 11 years in the University of Massachusetts system as a professor, understanding how to teach and learn chemistry. For the last 10 years, I've had a startup company called the Warner Babcock Institute and have been involved in inventing chemistry. And throughout the 30 past years, I've had the pleasure of working with the state of Massachusetts, the state of California, the United States federal government, looking at chemicals policy. And so I've had this unique opportunity to see from big industry, from academia, from startups, and from the other night. And I feel that for us to truly have a sustainable society in chemistry, we need to understand how we're doing chemistry, how we're learning chemistry, how we're inventing chemistry, and how we're managing chemistry. And the solutions won't come from one of those four pieces, but they must all come together to understand how to move forward. And so I'm surprised that I feel very old. It is now 20 years next year since this book came out. It's been a very long time. And I feel that if you pick up this book and you read the pages of this book, you say, well, this is obvious, this is straightforward, there's nothing very special in this book. Anybody could have written this book. It's just very common sense that we should use the tools of molecular science to understand and invent technologies that are more sustainable. And so I joke that I'm very lucky that Paul Anastas and I wrote this book, but honestly, anybody could have written this book. There's nothing crazy changing about it. It's just common sense. The 12 principles of green chemistry, in my opinion, are the necessary component of this, because it differentiates that green chemistry is not necessarily a policy, it is a field of science. It is the molecular level tools to accomplish the goals of sustainability. It isn't the discussion, it isn't the contemplation, it is the nuts and bolts activity of inventing. So these words are not going to appeal to people in marketing. These words will not appeal to people in sales. It speaks to the bench chemist, to the person pouring the beakers and flasks and inventing the chemistry to ask themselves how my decisions now might relate to these downstream discussions. Okay? And so to me, green chemistry, and this is very important to me, you should never tell somebody, you must embrace my technology because it's green. We're in a society where that's not enough. What you should have, yes, there must be some environmentally benign component to it, but it must have superior performance and it must have superior cost. And that if you have superior performance and superior cost, of course, industry will want it, people will want it, because it's just better. And so that's green chemistry. If government must have incentives or regulations to force industry to use technologies, we need to do that. We need laws to protect society. But elections can change and politics can change. And one day, look what's happening in the United States. Everything can change overnight. So the truly sustainable technology is when the scientist goes back in the lab and invents it to be better performance, better cost, and oh, by the way, it's better for the environment as well. And so from my perspective, the word sustainability is an overarching word that covers all aspects of society. We can have sustainable economics, we can have sustainable agriculture, we can have sustainable education, business, chemistry, engineering, everything. We can put sustainable before almost any word. When we talk about sustainable chemistry, we're talking about issues that are related to materials and molecules and things like that. So chemicals policy, remediation technology, exposure controls. green chemistry, water purification, alternative energy. There are many, many pieces of sustainable chemistry. I see green chemistry as a small part of sustainable chemistry. You see, from my perspective, a solar energy device is a sustainable chemistry technology. We desperately need alternative energy. But every solar panel today uses toxic materials, uses a great deal of energy in the manufacturing. So while it's a sustainable technology, it's not a green chemistry technology. Because green chemistry does not look at the application. It is not what the technology does, it's what the technology is. It's the building blocks. So it's just the part that looks at the solvents, looks at the catalysts, looks at the feedstocks, looks at the toxicity, looks at the persistence, the reduced energy. I have a bias. There are 12 principles of green chemistry, so there are 12 ways of looking at it, but it is agnostic to the application. It looks specifically at the building blocks. So green chemistry is a part with everybody else that is looking at the social issues. Sustainable chemistry is looking at all of these things. And green chemistry is that little piece that the person in the lab pouring the beakers and flasks, the job that they have in this much larger universe of problem solving. And so that's the way that I have chosen to look at green chemistry. And so the way I look at it, if you imagine all the products available to society today, the ceiling tiles, the carpeting and the flooring, the textiles, the electronics, I would argue maybe 10% are considered sustainable. 90% of all the technologies have needs for improvement in sustainability. If you do an alternatives assessment, if you seek what exists today that we could replace these technologies, I believe maybe 25% are capable of being discovered. But today in 2017, I would suggest that over 65% of the technologies have not been invented yet. So you could look at that and say, oh my God, this is terrible. Or you could say, what better time in human history to be a chemist? What better time in human history to be in the business of inventing technologies that are sustainable? And so from my perspective, we chemists have a lot of work to do. And we have a lot of job security because there's many things that need to be improved. But if you accept my definition that green chemistry has superior performance and superior cost, there are no real barriers to adoption that aren't a barrier to any new technology. You know, people were still manufacturing vacuum tubes long after the transistor was invented. Never in history did an incumbent technology lie down and say, please take me over. There's always been a pushback from an incumbent technology, and something that is sustainable is no different. And so the only barrier, though, in my opinion, that is different is the invention. And we have to ask ourselves, do we have a society capable of inventing these technologies? You know, we hear about the circular economy, okay, and I'm a big fan of the circular economy, where we look at natural resources, and then we look at manufacturing, and we look at distribution and use and collection, and we want to have this circle. The problem with a circle is, where is invention on a circle? It's already happening, so where does that invention come on? And so I think the circular economy is wonderful. This is not a criticism, but as an inventor, I put a twist in it, and I look at it as a Mobius strip, where you have the circular economy, but superimposed in every moment is basic research, applied research, development, scale-up, commercialization, and we understand the market, we understand research, and we must be intimately connected to both to be able to produce new technologies that are truly sustainable. And so both must coexist. One can't be over here in a university and another be over here in the market. There must be some superimposition for us to be successful. And what I love about this organization and what the goals you're trying to accomplish here is to, in fact, create an infrastructure to support that. So after 10 years at Polaroid and 11 years at the university, 10 years ago in 2007, we created the Warner Babcock Institute for Green Chemistry. It's a small startup company. Jim Babcock is the sole investor, and Joe Pont, who's in the audience, is the CEO. It's a little bit north of Boston, Massachusetts here in Wilmington, Mass. It is a beautiful 42,000 square foot facility. I think it's about 5,000 square meters. It's a very large facility with every piece of research equipment that a university would have to synthesize small molecules, to make polymers, to extrude plastics, to fabricate devices and then test those devices. And so it's a very thorough thing. And with about 30 PhD scientists and master's and bachelor scientists that are working 24/7 to invent. And so the way I look at it is, if you think about science, what do we do in science? We look at a phenomenon and we imagine we understand it, and we propose an experiment, and if that experiment works, we pat ourselves on the head and say, we understand this science. And we call that basic research. But what do we do in business? We have a product, we have a market. If we poke the product, we want to predict how the market will respond. And if we do a good job, we pat ourselves on the head. The intellectual process of science and business actually has more commonality than we often consider. And that what I look at is, I say there are many technology incubators. There are many places in the world where people are trying to take prototypes and move them to commercialization. But this process does not succeed very often. And so what I consider the Warner Babcock Institute is not a technology incubator, but what I call a technology greenhouse, in which we go from idea to prototype, and we put an equal emphasis on science and business. And so we don't want to have a technology that once we try to commercialize it, we discover then and only then that there are sustainability issues. That if you consider the sustainability issues in the earlier part of the design, then you will be more successful. So the Warner Babcock Institute, interestingly enough, our biggest model, what we do most of the time, about 80% of the time, is what I call contract invention. We work with large, medium, and small companies, and we invent technologies. I never put the names of companies. I don't have logos. Look at these companies that we work with. But we've worked with almost 100 companies in the last 10 years. And if you search my patents and see who they're assigned to, you can figure out who we're working with. But I don't talk about that in public. We also have a lot of government grants. Okay, and so NASA, Department of Energy, and DARPA has funded a lot of some of the technologies that we do. But our investor is this organization called Cthulhu Ventures. Very difficult word, all right? Don't get me started, okay? And what we do is we do invention licensing. We invent something with internal support, and then we go and we license it. But then sometimes when we're inventing things, we decide to spin out companies ourselves. So we have a material science company called Collaborative Aggregates. And with that, we have a wood composite technology and we have an asphalt technology. And then we spun out a medicinal chemistry, a pharmaceutical company, in which we have an oncology program and we have a neuroscience program. And so the small group with only 30 people and not a massive amount of funding has a network of collaborators where we're doing a lot of things in many different areas, not because being spread out is difficult to manage, but from a chemistry perspective, and this is going to be a theme I go over very often, from a chemistry perspective, there's a lot of commonality in all of the things we're doing. Okay? I'll give you some examples of that. We also have a nonprofit called Beyond Benign, and this is a university in K-12 STEM education program where we are trying to help develop curriculum. So with all of the for-profit things we're doing, we also focus a great deal of emphasis on the nonprofit organization Beyond Benign that is creating curriculum for K-12 in universities. So one example that I'm very proud of is there is this molecule called copper ATSM. It's a copper ligand salt. This thing is virtually insoluble. You cannot do anything with it. If you take some surfactants and some DMSO and present it to some laboratory animals, you see that it works very well for a lot of neurological disorders. But of course, you can't give humans these surfactants and these things. And so with a technology we call non-covalent derivatization, we've created a water-soluble, biologically available form of this. And very quickly, after we developed this thing, the Michael J. Fox Foundation provided support, and very quickly it went into phase 1 clinical trials. And we're very excited about the results of this for an ALS, as an ALS drug. And you can go on clinicaltrials.gov and look at what's going on. We're very excited about this. We also have an Alzheimer's technology, in which we've been very fortunate that we've got this thing down to nanomolar activity. Okay, and so there's nice results. Now, what's interesting is if you come to my institute, the person synthesizing these molecules are the same person that's working in asphalt pavement. In the United States, there is 1 billion miles of asphalt pavement in the United States. And what happens is every year the sun and the air oxidize the surface of the pavement, making it brittle and cracked. And so 10% must be repaved every year. But that stuff that they dig up is too brittle and hard, so it goes to a landfill. Maybe they'll use 5% and repave, but most of it's being wasted. And all that raw material is being wasted. So I was looking at that and I said, why can't I come up with an additive that allows me to reuse all of the asphalt? And so a few years ago, in 2013, we dug up my driveway at my house. Okay, my wife was not very happy. We dug up with a perfectly good driveway. And I went and I had some contractors come. It was below 20 degrees Fahrenheit, so very cold. We used over 50% recycled material. The workers that came were laughing at me. They said, John, we're gonna open up this truck and a big hockey puck is gonna fall on your front lawn. We can't do this. And I had someone from the State Department of Transportation there watching this trial. I was very nervous. I say, okay, go ahead, do it. They open up the truck. The asphalt comes smoothly out. They jump on their bulldozers, and here it is, 2 years later. It works remarkably well. It allows us to take all the recycled material and reuse it. It works so fast that 11 months after this trial, we started a company called Collaborative Aggregates. I wanted to call the product Entropy Mix. But the people marketing it said, oh, John, that's terrible. What a terrible name, Entropy Mix. So I said, how about if we name it Delta S? They go, oh, that's good. So no one tell them, okay? And so now we have 37 states in the United States that have approved this for state roads as a way, and what's interesting, it also lowers the processing temperature. When you fill up a truck, the asphalt is very hot. And you have to look at the time because it's going to cool down. This allows it to be processed much lower temperature, so it extends the paving day by more than an hour. Better performance, better cost, and oh, by the way, it's more sustainable. Now, this is a strange thing. This is me. I'm wearing a hard hat, I'm wearing boots, I'm holding a shovel, and I'm digging in asphalt. And my cell phone rings, and it's clinicians from Finland explaining to me about the neurological results, the cognition studies of the animals. Now, most people would look at this and say, that is very strange. Someone digging in asphalt doing neuroscience. But wait, my Alzheimer's model is an organic polymer wrapped around an inorganic particle. Delta S is a small molecule that slips into the interface and controls the way it aggregates. What is asphalt pavement? An organic polymer wrapped around an inorganic particle that controls the way that it aggregates. That invention doesn't happen in the focal point. Invention happens in the periphery. And for you to be inventive, you must always be putting things in the periphery. So interestingly enough, it is the same chemistry. The Alzheimer's drug puts asphalt in the peripheral vision. When I'm looking at asphalt, it puts the Alzheimer's in the peripheral vision, but the molecules don't know what industry they are in. They're just molecules. And so we get so caught up. I am a pharmaceutical scientist. I am a cosmetic scientist. Molecules don't care. And if we're going to solve problems for society, we need to embrace that larger vision. Okay, so we also have a wood composite technology. You're probably familiar with the formaldehyde off-gassing in wood composites that's been going around. We had a 70-ton pilot scale run in Canada of OSB lumber, oriented strand board lumber, that has better performance than industry standard, better cost than industry standard, not a drop of formaldehyde, not a drop of MDI. There's another technology we're excited about. Here's another story. I can't explain why these things happen. One day, I was thinking about insects. And when an insect gets bigger, its exoskeleton cannot grow. So it breaks off its exoskeleton, and over the course of a couple hours, it turns hard and black. I looked into this and I said that hair color could use this. Here's something in nature that goes from white to black. But it's in nature, it's a natural process. So I looked up the process, and it turns out that it's an enzymatic process called a tyrosinase oxidative cascade. So I did not grind up bugs. I came up with chemistry from seed extracts that mimic this. I put it in a beaker, I got some gray hair, and it worked. It recolored the hair. But what was interesting, it doesn't color the hair, it restores the hair to its original color. So it recreates the human pigment. What I really discovered is that your hair templates the color hair. We have all the same molecules, and the way it packs in our hair dictates its color. So I am the most gray person at the Institute, so I jump in a hair, I say, hit me! And my hair goes back to the color it was 30 years ago. Someone with black hair that's gone gray, it goes back black. Someone with brown hair, it goes back. So it restores the human pigment, non-toxic, no smell. So the same way that our fingers have a fingerprint, our hair has a hairprint. So I licensed it to a company called Hairprint, and for the last 2 years now, online for $39.99, you can get a box of Hairprint and color your hair back to its original color. It's a successful product in the market. The famous sustainability author, Paul Hawken, he wrote Ecology of Commerce, and he's the licensee, so it's his company that now sells this product. Another technology, we looked at DNA photo cross-linking. People who suffer from psoriasis have a technology where they shine UV light on psoriasis to cure them. It's called PUVA phototherapy. What happens is the thymine in the DNA undergoes a chemical reaction. And so what I did was I took thymine out of DNA and put it into synthetic polymers or biopolymers. Styrenes, acrylates, PLA, cellulosics, and what ends up happening is it does this cross-linking, so we have hair curling technology and fabric control with pleats and wrinkle resistance based on this DNA mimic in technology. Here's another crazy story. On June 29th, 2015, I found myself at the United Nations General Assembly center stage. There's my big head there. What happened was 2 weeks earlier, this cable show called Whale Wars, that these people chase illegal fisher people doing illegal things in the ocean, they called me and they said that they had 75 tons of illegal fishing net. And a company wanted me to help them. So they sent a bunch of the fishing net. We had 2 weeks to separate the nylon from the polypropylene, to pull out the pigment, to pull out the heavy metals, extrude it to a certain dimension. We did this very, very quick in 10 days. We sent it to Germany, to Adidas, and standing beside me on the center stage of the United Nations, men from the board of directors of Adidas holding up their 2016 running shoe made out of ocean plastics. That was invented at the Babcock Institute, that process for doing it. Electronics and recycling, we looked at orange oil. The extract from orange oil is limonene. Again, I can't explain why these crazy ideas come to me, but what I did is, if I can take limonene and hydrolyze it 50% to a 50% mixture of limonene and limonol, and then disperse it in water, I can get the perfect density so that if you take a lithium cobalt battery and grind it up, you can float the lithium cobalt out of it and get 100% recovery of lithium cobalt from lithium batteries using limonene. Okay, not kerosene, not flammable explosive things, but water and orange oil. We have a water harvesting technology where we have a polymer that, when you shine light on it, is hydrophilic. When you put it in the dark, it's hydrophobic. Imagine, this is an oversimplification, but imagine a rowboat on the ocean. You have an umbrella. Under the umbrella, you've got this polymer. When the sun comes up, water absorbs on the underside of the umbrella. When the sun goes down, it rains pure water in the rowboat. This is an oversimplification. We actually make it going fast so that it will work in the shadow of a windmill, that we can capture and release water so as to harvest water. So my point here to do these discussions is just really to give you a very quick review of what a group of people can do. We are no smarter, we are no more creative, we are no more imaginative than any other group of chemists. What I just described here is 3 years worth of work, 20% of 20 people. So it's a tiny group of people, tiny amount of resources with going. But the reason is the following, and I think this is my final statement. If I had a group of scientists, and I said to a group of scientists, you can never use a molecule that begins with the letter D. Now that's silly, but okay. Those scientists would have to think about everything different. They could never use the letter D in anything. And so if all the chemists in the world are reading the same journals, reading the same textbooks, taking the same classes, then they're all doing the same thing. If you choose not to use the letter D, it forces you to approach problems from a different perspective. And I would add, you would be more innovative and you'd be more creative. Now, the letter D, that's silly. What the Warner Babcock Institute does is he says, our constraint is green chemistry. We will only work with materials that are non-toxic, that are environmentally benign. And interestingly enough, it forces us to approach problems from a different perspective than everybody else. And instead of slowing us down, the secret is it speeds us up. And so looking at sustainability, because you know what? When we invent something, usually in industry, when someone invents something, it's a great idea, but it's later in the process someone identifies a fatal flaw. They say, wait a minute, we can't use that solvent, we can't use that reagent, and it's usually because of sustainable regulatory issue. But if that science is invented understanding that in the first place, you are faster to market. Your time to market is quicker, your costs of manufacturing and scale up are less, and so it's one of these times when you can do really cutting-edge science, but get to market faster. And that is the secret that anyone who understands sustainability and understands chemistry, once that makes sense, it's something that's universal. But you know what? We still have probably 10, 15 years before the whole world figures this out. So organizations like this one, that is a network of people that are collaborating to take advantage of this, going to do excellent science, but will also do extremely meaningful things for society. And the world desperately needs you to do that. So I applaud the efforts in creating this entity and wish you the best of luck and offer whatever help that I can in doing this. Thank you.